Hello everyone. So today we will discuss how writes are so hard to scale basically, and we will see how big tech handles billions of writes per second. So reads can often be distributed across replicas and cache. However, writes must be the source of the truth, and this introduced like conflicts and consistency issues. So some of the common write bottlenecks include disk input output limits. Database can't like flush transactions fast enough, and there is also lock contention. Multiple writes to the same row key can cause blocking, and also the network saturation. High frequency writes overwhelm the bandwidth, and hotkeys. A few popular users or entities attract a disproportionate number of writes. So what I'll do is I'll write down the challenges here and what are the bottlenecks here. So disk IO is there, and lock contention, network saturation, and hotkeys. So there are some strategies to scale the writes. So there are four core strategies to scale write. There is vertical scaling and write optimization. Another is sharding and partitioning, and another is handling burst with queues and load shedding, and the last one is batching and hierarchical aggression. So I'll try to write it down here. Vertical scaling is there, sharding is there, with queues, and batching. So as systems grows, write operations become most main bottleneck, not because writing is inherently hard, but because consistency, coordination, and durability make it expensive. And let's talk about these. So vertical scaling and write optimization. Basically, before scaling horizontally, squeeze every drop of the performance from your existing setup. That means use everything that is there. So this is often the cheapest and most straightforward improvement path. And sorry, in vertical scaling at its core, so it often called like scaling up involves improving your existing database server hardware capacity and tuning the low level configurations. You can utilize faster SSDs, more RAM, better CPUs, and the database level optimizations can be there. We can utilize OLTP databases like Postgres and MySQL, and LSM tree based databases like Cassandra, RocksDB, LevelDB, and log structure systems are there, for example, Kafka and Clockhouse. So, what are the advantages of vertical scaling? So, it is often the simplest and the fastest. And by upgrading your hardware like SSD, CPU, memory, you can achieve immediate performance gains. There is some disadvantages as well. For example, vertical scaling has hard physical limit. There is only so much CPU or memory you can add, and this introduces single point of failure as well. Another we will discuss is sharding. So basically, there are horizontal sharding, and in which basically we split the data across multiple servers by keys, for example, user ID, and each shard handles a subset of the traffic. And there is vertical partitioning as well. So you can split tables by functionality, for example, user in one database and payments in another. And advantages of sharding and partitioning are like distribute workload across multiple servers, massively improve scalability. And there is disadvantage as well. The biggest drawback is complexity. You must careful with the design you shard, how you design your shard keys to avoid some hot shards and ensure even data distribution. And the third one is handling burst with queues. So even well sharded systems can fail under traffic spikes. To absorb that traffic, we have to decouple writes using queues. So queues basically, instead of writing directly to the database, we can accept writes into queue, for example, Kafka and RabbitMQ, and we can process them asynchronously in the background. And the load shedding is, if the queue fills up or downstream system lags, you may drop non-critical writes or degrade gracefully, and you can have rate limit clients as well. There is advantages and disadvantages as well. You can get, like, it helps in decoupling the writes from the direct database operations, and this allows your system to handle traffic spikes gracefully. But there is disadvantages as well. So downside is like increased latency you can get and the complexity you have to take care. Queues require monitoring, scaling, and retry management as well. So to ensure exactly one's delivery semantics, it is like non-trivial. The last one is batching, and it also known as like hierarchical aggression. So in batching, we can combine multiple small writes into one large transaction, and hierarchical aggression is like aggregate data at multiple layers. You can have like local cache or edge nodes aggregation, right? And there is advantages and disadvantages as well. Like you can get combining multiple small writes into larger efficient transaction, but as a disadvantage, you can have like the main trade-off is like accuracy and the latency. So aggregated data may be eventually consistent. It is also adds architectural complexity. You must manage multiple layers of cache or immediate stores and define synchronization intervals carefully. So the hard truth is like there is no universal fix. You scale vertically to buy time and simplicity. You shard with when you grow on demands distribution. You queue to absorb unpredictable burst. You batch to make operation efficient and predictable. So that was it. Thank you.